August 18th, 1868. The moon moves over the sun in a solar eclipse. The atmosphere of Guntur, India goes silent, and a French astronomer points his spectroscope to the sky. He doesn't get much time. There's just a sliver of light and a color that shouldn't exist. A single, defiant yellow stripe in the rainbow. It doesn't match with sodium or gold or anything on Earth. Yet there it is, waving at the astronomer from the sun's edge. One blink and the eclipse is gone, but the discovery has already been made. We found a new element in space before we found it at home. That yellow smudge? Helium. And it's quietly running your next MRI. Hello and welcome to Meet the Elements, a series where I use the periodic table as a lens to explore the stories of humanity. Helium is the universe's ultimate introvert. It's the second most abundant element out there, but on Earth, it's a ghost. Colorless, odorless, and so standoffish it refuses to react with anything. But chill this cosmic wallflower down to 4 degrees above absolute zero, and it transforms into a bizarre form of matter. It becomes a superfluid, a quantum state of matter with zero friction and zero viscosity. It climbs walls, slips through microscopic cracks, and once you start it swirling, it will keep spinning. This isn't a mere physics curiosity. Supercool helium is the silent partner in advanced technology, enabling things from life-saving medical scans to breakthroughs in physics. It all started because one guy gambled on a cloudy day and spotting some light no one had ever seen before. By the middle of the 19th century, the spectroscope, the newest toy of scientific discovery, had turned light into a language. Funnel light through a prism and it refracts and splits into its component colors. Do this with light produced from heating an element, and you get a fingerprint written in sharp, bright lines of color. Enter Pierre Janssen. He slips out of Europe, hauls his equipment of glass and brass to India to point his spectroscope to the sun during a solar eclipse. In the town of Guntur, nestled between the mountains and the sea, Janssen set up his observation equipment. However, it rained for several days before the eclipse. It was looking like Janssen dragged his equipment halfway across the world for nothing. But on August 18th, 1868, the sun rose above the mist and shone brightly. Janssen collected his data during the eclipse. According to Janssen's account, the sun shone with light that was like the flame of a forge fire. But there was something peculiar with the spectrum of light Janssen collected. In the region one might expect to see the 2 yellow lines characteristic of sodium, Janssen saw a single yellow line. Weeks later, his report electrified the scientific community. He'd found a spectral line that belonged to an element unknown to Earth. Across the English Channel, Norman Lockyer confirms Janssen's discovery, figuring out how to view the same spectral line by focusing on the sun's edge. Lockyer gave this new element a fitting name, Helium, after Helios, the Greek god of the sun. It was the first element discovered in the heavens before ever being found on Earth. For the next 27 years, helium remains a cosmic anomaly. Astronomers have proof it exists, but chemists can't find it on Earth. In comes William Ramsay, a Scottish chemist who contributed heavily to the discovery of the noble gases. Ramsay cooks uranium ore with sulfuric acid, capturing the resulting gas, and looks at it through a spectroscope. That same cheeky yellow line that Janssen saw flashes back. Helium had been seeping out of uranium like a leaky birthday balloon this whole time. While Ramsay couldn't know about uranium's radioactive nature when he isolated helium, since radioactivity wasn't discovered until the following year, we now know that uranium emits alpha particles as it decays, alpha particles being helium nuclei. Shortly after Ramsay proved helium's terrestrial existence, Swedish chemists managed to do the same. Overnight, helium went from astronomical quirk to laboratory curiosity without ever becoming useful. But helium didn't remain useless for long. In 1908, Dutch physicist Heike Kamerlingh Onnes liquefied helium, creating a bath of pale, bubbling liquid at a mind-numbing 4.2 Kelvin, just 4 degrees above absolute zero. This was more than just an extremely cold liquid, it was the key to new technologies. 3 years later, Onnes used his liquid helium to see what happened to electrical resistance at these extreme temperatures. He expected it to get very, very low. Instead, the resistance vanished entirely. Onnes had discovered superconductivity, a state where electricity flows with zero loss forever. You can try to think of it like this. If you were to supercool your phone, ignoring any other concerns that might arise from doing so, it would remain fully charged no matter how much you used it. It was a discovery that would have been impossible without liquid helium as the ultimate refrigerant. And while we don't have phones with infinite batteries, liquid helium still serves a vital role in research and medicine. An MRI magnet is a coil of wire bathed in a bathtub of liquid helium. One stray heat spike and the coil quenches. Resistance returns, energy dumps as heat, and a hospital loses a lot of money and time. Superfluid helium conducts heat 1,000 times better than copper, keeping magnets colder than deep space, so protons can whip around without frying the hardware. Now here's the cruel irony. Once helium escapes, it's gone. It's light enough to rapidly reach escape velocity as it rises. Every atom of helium we use is a gift from radioactive ores within the Earth's crust, trapped in gas pockets for eons. The US Federal Helium Reserve was mandated to sell off its stock in 1996. Meanwhile, party stores sell tanks for less than $50. Pop a balloon and that helium wafts irretrievably toward the stratosphere. Medical grade prices have risen substantially. Hospitals, research labs, and drug manufacturers are beginning to reclaim helium like bootleggers guarding a still. The element that was found in sunlight is now pricier than the other noble gases. From a short eclipse in India to the magnet that lets doctors look at your organs, helium has quite the story. Forged in the Big Bang, cooked in stars, spotted in sunlight, extracted from uranium, and now used in hospitals everywhere. One leak away from leaving Earth forever. So when you suck in a breath of helium for a squeaky voice, remember, that atom survived radioactive decay and is on a one-way trip to space once it slips past your lips. Treat it gently, because the universe isn't refilling the tank, and your next MRI depends on every atom we can keep. Thanks for watching. Helium is one of those elements that you tend not to think about all that often. Its lack of chemical reactivity means it doesn't show up that much in our lives, but when it does, it is certainly memorable. But do you think I left anything out about helium? Is there any story surrounding the element that you find interesting? Let me know down in the comments. And don't forget to leave a suggestion for the next element I take a look at. And if you want even more videos about the periodic table of elements, make sure to subscribe so you don't miss the next episode of Meet the Elements.